Good day, friends, and welcome to this class. In the course of this video lesson, we're going to be solving past questions on simple machines. Now, this is a jam past question, and it says the velocity ratio of a machine is 5. Its efficiency is 75%. What effort would be needed to lift a load of 150 Newton with the machine? In this question, they give us the velocity ratio of the machine, and it's 5. They give us the efficiency, which is in percentage, 75%. Then they ask us the effort that will be needed to lift a load of 150 Newton. They give us the load, 150 Newton, and they ask us to calculate for the effort. Now, we know that the formula that we can use to calculate for effort is this formula: mechanical advantage is equal to load over effort. This is the formula. But in this question, we are not given mechanical advantage. In this question, we aren't given the mechanical advantage, but we are given the efficiency. And we know that efficiency is equal to mechanical advantage all over velocity ratio. So they give us efficiency here, they give us velocity ratio here, so we can calculate for the mechanical advantage. So the efficiency from the question is 75%, which is 75 all over 100. That is 75%, is equal to mechanical advantage, we don't know, all over velocity ratio is 5. Alright? Now when we get to this point, for clarity, we can just cross multiply. 75 times 5. Okay, we can do MA times 100, you have 100 MA. That is mechanical advantage, is equal to 75 times 5 is 375. 375, yes. Now we divide both sides because we are looking for the mechanical advantage MA. So we can just divide both sides by 100. This will cancel out this. Then the mechanical advantage is equal to 375 divided by 100. We have 3.75. This is the mechanical advantage. So with this mechanical advantage, we can calculate for the effort in this question. Now we can just use this formula then. Mechanical advantage, let me solve it here. Mechanical advantage is equal to load over effort. Now the mechanical advantage is already 3.75, so we can just substitute here. MA is 3.75 is equal to, what is the load? The load is 150 Newton, so 150 all over, what's the effort? We don't know. That's what we have to calculate for. So the same thing, you just cross multiply. You multiply here, just for clarity's sake. Then 3.75 times E. 3.75 times E, I'm cross multiplying. So you're having is equal to 3.75 E. Okay. Then 150 times 1 is equal to 150. Now what do? Simply, you just divide both sides by 3.75. Divide here by 3.75. This will cancel out this. The effort then is equal to 150 divided by 3.75 is 40. It's 40. 40 what? 40 Newton. Because effort is in Newton, just as load is also in Newton. Alright? So the effort then is 40 Newton. So can you see now that a load of 150 Newton can, that is a machine can enable a load of 150 Newton to just be, for a little force of 40 Newton to be applied on it. Because we say that machine is a device which enables a bigger load to be overcome by little effort. The load is bigger here, 150 Newton. And it is overcome by a smaller force of 40 Newton. That shows that it is a machine. Thank you very much for watching. Please drop a like, drop a comment, and also follow my Facebook page. It says a wheel and axle is used to raise a load of 500 Newton by the application of an effort of 200 Newton. If the radii of the wheel and axle are 0.4 cm and 0.1 cm respectively, the efficiency of the machine is dash. This question is different, but it is very easy. They say a wheel and axle. A wheel and axle is a machine. Alright? Now, it is used to raise a load of, they give us a load of 500 Newton. They gave us the effort of 250 Newton, but they gave us the radii of the wheel and axle. Now, the velocity ratio or the way we calculate for velocity ratio of different machines with different formulas. For wheel and axle, the velocity ratio of wheel and axle, the formula is wheel all over axle. Alright? Wheel over axle. I'm going to make a video and state the whole formulas we use for different machines. But for wheel and axle, the formula is wheel over axle. Now, where is the wheel here? Because they said if the radii of the wheel and axle are 0.4 cm and 0.1 cm respectively, so the wheel is 0.4 cm and the axle is 0.1 cm. No, we are calculating for the velocity ratio, because the velocity ratio of the wheel and axle is wheel over axle. 0.4 divided by 0.1 is 4. Alright, now we have the velocity ratio and they say we should calculate for the efficiency. But we've not calculated for the because see, if we want to calculate for efficiency is equal to mechanical advantage MA over velocity ratio times 100 over 1. We have not calculated for the mechanical advantage. So you see that we have to calculate for it. And it is very easy for us to calculate for it because we're giving the load and the effort. So we can just simply put here. Let me solve it here. Mechanical advantage is equal to load over effort. Mechanical advantage is equal to, what's the load? The load is 500 Newton. All over the effort. The effort is 250. So the mechanical advantage, 500 divided by 250 is 2. Alright, now we can now calculate for the efficiency because we have the mechanical advantage, we have the velocity ratio, and that's all. Efficiency, mechanical advantage is equal to, mechanical advantage is 2, all over velocity ratio is 4 times 100 over 1. For simplicity, to make things simpler, efficiency is equal to 2 times 100, 200 over 4. Just divide this, you have 50. 50 what? Efficiency is measured in percentage, 50%. Can you see how we solve questions on wheel and axle? Please take note that the velocity ratio of wheel and axle is wheel over axle. That is it. Alright? Please follow my page, direct your friends, call your friends to come and meet Instructor Uche in his page. My YouTube channel, I explain physics to the core. Because I'm also a student, so I know the areas that students find difficult and I focus on those areas. Thank you very much. A machine whose efficiency is 60% has a velocity ratio of 5. If a force of 500 Newton is applied to lift a load of P, what is the magnitude of P? They say a machine whose efficiency is 60, they give us efficiency 60%. And it has a velocity ratio of 5, yes? If a force of 500 Newton is applied, which is the effort, okay? The effort of 500 Newton is applied to lift a load of P. Can you see where the problem is? They give us P as the value of the load. They did not give us a figure. Then they asked us to calculate for the magnitude of P. That is the value that is supposed to be there. That is what we're going to do now. Now, so they gave us efficiency, they gave us velocity ratio, they gave us effort that they say to calculate for load. Now, if we are to calculate for the load, we use the formula for mechanical advantage is equal to load over effort. But we are not giving mechanical advantage. We are only giving efficiency. So this formula will be on the standby. Then we use efficiency is equal to mechanical advantage all over velocity ratio. Now, efficiency here is 60%. So it is 60 over 100. Please take note. So efficiency is 60 over 100. That is 60% is equal to, we will look for the mechanical advantage first. All over velocity ratio is 5. Simple. Then you just cross multiply like we've been doing before. 100 times MA, you have 100 MA is equal to 60 times 5 is 300, right? 300. Then what do? You divide both sides by 100 because we're looking for the mechanical advantage, which is MA. So you divide here by 100, divide here by 100. This will cancel this out. Then the mechanical advantage is equal to 3. So since we've gotten the mechanical advantage, we can calculate for the value of the load, which is P. Alright? So I'll bring it here. Mechanical advantage is equal to load over effort. What's the mechanical advantage? 3 is equal to, what's the load? From the question, they gave us the load to be what? P. Please follow me. Is equal to the effort is what? 500. So what do? You just simply the same cross multiply, make it over 1. So it will be balanced. There's a fraction here, there's a fraction here. You just cross multiply. I'm doing this for simplicity. Alright? So P times 1 is equal to P. 3 times 500 is equal to 1,500. 1,500 what? Newton. Alright? So the value of P, or the magnitude of P, which is the load, is 1,500 Newton. So can you see that the load is bigger than the effort? That is why it is a machine. A machine is a device which enables a bigger load to be overcome by little effort. Physics is fun. Physics is interesting. You just need a tutor, a person that will be teaching you one step at a time. And please, that is why you need my page. Please, my YouTube channel will post it in the comment section. Please, let's grow the page together. Please, I beg you. If you are viewing it, please react to it. Thank you very much.